find plans for a single-phase to three-phase rotary converter, you can explore several avenues. Firstly, there are online resources such as Instructables, which often feature step-by-step guides for building your own converter. Electronics Notes provides articles on power electronics, including single-phase to three-phase conversion techniques. eBay and Amazon may have listings for plans and instructions manuals, or ebooks detailing the construction of rotary converters. Secondly, consider books and publications. There are guides like Build a Single-Phase to Three-Phase Rotary Converter and Single-Phase to Three-Phase Power Conversion that offer in-depth information. Thirdly, community forums and groups like Practical Machinist, Die-or-Not, and Reddit's r/electronics are great places to find discussions, shared experiences, and advice from others who have built or are knowledgeable about rotary converters. When working with electrical systems, it's crucial to exercise caution. High voltages and currents can be dangerous, and improper wiring can lead to equipment damage, fire hazards, or even electric shock. If you're not comfortable working with electricity, or if you have any doubts about your ability to safely construct and install a rotary converter, consult a qualified electrician. An electrician can ensure that the converter is properly sized for your application, that it's wired correctly, and that it meets all applicable electrical codes and safety standards. Rotary converters work by using a motor generator set to convert single-phase power into three-phase power. A single-phase motor is used to drive a three-phase generator. The generator then produces three-phase power that can be used to run three-phase equipment. Rotary converters are typically used in situations where three-phase power is not readily available, such as in rural areas or in small shops. There are two main types of rotary converters, namely idler type and autotransformer type. The idler type uses an induction motor as an idler to generate the third phase. The autotransformer type uses an autotransformer to create a pseudo three-phase output. Selecting the right type of rotary converter depends on the specific application and the type of load that will be powered. When choosing a rotary converter, it's important to consider the voltage and current requirements of the three-phase equipment that will be powered by the converter. The converter must be able to provide enough power to start and run the equipment. It's also important to consider the duty cycle of the equipment. If the equipment will be used continuously, then a larger converter will be needed. The size of the motor used in the rotary converter is important. It needs to be adequately sized to handle the load. If the motor is too small, it will overheat and fail. The capacitors used in the rotary converter are also important. They help to improve the power factor of the converter and reduce voltage fluctuations. The wiring of the rotary converter must be done correctly to ensure safe and reliable operation. It's important to use the correct wire size and to make sure that all connections are tight. Grounding is also very important for safety. The converter must be properly grounded to protect against electric shock. When installing a rotary converter, it's important to follow all applicable electrical codes and safety standards. It's also important to consult a qualified electrician to ensure that the converter is installed correctly. Rotary converters can be a cost-effective way to provide three-phase power in situations where it's not readily available. However, they are not as efficient as directly using three-phase power, and they can introduce some voltage imbalance and harmonic distortion. Properly sized and installed rotary converters can provide years of reliable service. Regular maintenance, such as checking the motor bearings and cleaning the windings, can help to extend the life of the converter. Also, understanding the different types of single-phase to three-phase conversion methods, including static converters and variable frequency drives, is crucial for selecting the right solution. Static converters use electronic components to synthesize a three-phase output from a single-phase input, while variable frequency drives rectify the single-phase alternating current into direct current and then invert it back into three-phase alternating current with adjustable frequency and voltage. The choice depends on factors such as load requirements, efficiency, and cost. When designing or building a rotary converter, consider the potential for voltage imbalances between the three phases. Voltage imbalance can cause motors to overheat and reduce their lifespan. Using balancing capacitors and carefully selecting the components can minimize voltage imbalance. Also, harmonic distortion can be introduced by rotary converters, which can affect the performance of sensitive electronic equipment. Using filters and reactors can reduce harmonic distortion. The single-phase input voltage and current should be carefully monitored to prevent overloading the single-phase circuit. Overloading can cause the circuit breaker to trip or damage the wiring. Proper overcurrent protection is essential for safe operation. The three-phase output voltage and current should also be monitored to ensure that they are within the acceptable range for the connected equipment. Overvoltage or overcurrent can damage the equipment. It's important to consider the environmental conditions in which the rotary converter will be operating. High temperatures, humidity, and dust can affect the performance and lifespan of the converter. Choosing components that are rated for the specific environmental conditions is crucial. Regular inspections and maintenance are essential for ensuring the safe and reliable operation of the rotary converter. Checking the wiring, connections, and components for signs of wear and tear can prevent potential problems. Consider the power factor of the three-phase load that will be powered by the rotary converter. A low power factor can increase the current draw and reduce the efficiency of the converter. Using power factor correction capacitors can improve the power factor and reduce the current draw. When selecting a rotary converter, it's important to consider the manufacturer's reputation and warranty. A reputable manufacturer will offer a warranty that covers defects in materials and workmanship. The installation location should be well ventilated to prevent overheating. Adequate ventilation is essential for dissipating the heat generated by the motor and other components. The rotary converter should be installed on a stable and level surface to prevent vibration and noise. Vibration can damage the components and reduce the lifespan of the converter. It's important to use the correct size and type of wire for the connections to the rotary converter. Undersized wiring can cause voltage drop and overheating. The connection should be tight and secure to prevent arcing and loose connections. Arcing can cause damage to the components and create a fire hazard. The rotary converter should be protected from moisture and dust to prevent corrosion and damage. A clean and dry environment is essential for reliable operation. The rotary converter should be inspected regularly for signs of wear and tear. Any damaged component should be replaced immediately. The motor bearing should be lubricated regularly to prevent wear and tear. The motor winding should be cleaned regularly to remove dust and debris. The capacitors should be checked regularly for signs of leakage or damage. Leaking or damaged capacitors can cause voltage fluctuations and reduce the efficiency of the converter. The control panel should be checked regularly for proper operation. The switches, buttons, and indicators should be functioning correctly. The overload protection devices should be tested regularly to ensure that they are functioning properly. The grounding system should be tested regularly to ensure that it is providing adequate protection against electric shock. When troubleshooting a rotary converter, it's important to follow a systematic approach. Start by checking the input voltage and current. Then check the output voltage and current. If either the input or output voltage or current is not within the acceptable range, then there may be a problem with the converter. Check the wiring and connections for loose connections or damage. Check the components for signs of wear and tear. If you're not able to troubleshoot the problem yourself, then consult a qualified electrician. They have the knowledge and experience to diagnose and repair the problem. When replacing components, it's important to use the correct type and size. Using the wrong type or size of component can damage the converter. Follow the manufacturer's instructions for replacing components. Improper installation can damage the converter or create a safety hazard. When working on a rotary converter, always disconnect the power supply before beginning any work. This will prevent electric shock. Use caution when working with electricity. High voltages and currents can be dangerous. If you're not comfortable working with electricity, then consult a qualified electrician. They have the knowledge and experience to safely work with electricity. When disposing of a rotary converter, follow all applicable local, state, and federal regulations. Some components may contain hazardous materials that must be disposed of properly. Consider the efficiency of the rotary converter when selecting a model. A more efficient converter will use less energy and save money on electricity bills. The efficiency of a rotary converter is typically expressed as a percentage. A higher percentage indicates a more efficient converter. Consider the noise level of the rotary converter when selecting a model. Some converters can be quite noisy, which can be a problem in residential or commercial settings. The noise level of a rotary converter is typically expressed in decibels. A lower decibel level indicates a quieter converter. Consider the size and weight of the rotary converter when selecting a model. Some converters can be quite large and heavy, which can make them difficult to install and move. The size and weight of a rotary converter are typically expressed in inches and pounds, respectively. Consider the cost of the rotary converter when selecting a model. The cost of a converter can vary depending on the size, features, and manufacturer. It's important to compare the costs of different models before making a decision. When comparing the costs of different models, be sure to consider the total cost of ownership, including the cost of installation, maintenance, and electricity. A lower initial cost may not always be the best option if the converter is expensive to operate or maintain. Consider the availability of spare parts when selecting a rotary converter. If a component fails, it's important to be able to obtain a replacement quickly and easily. Check with the manufacturer or supplier to see if spare parts are readily available. Consider the technical support that is available from the manufacturer or supplier. If you have any questions or problems with the converter, it's important to be able to get help from a knowledgeable source. Check with the manufacturer or supplier to see what type of technical support is available. Consider the warranty that is offered by the manufacturer. A good warranty will protect you against defects in materials and workmanship. Read the warranty carefully to understand the terms and conditions. Consider the reviews and ratings that are available online. Online reviews and ratings can provide valuable insights into the performance and reliability of different models of rotary converters. Be sure to read reviews from a variety of sources before making a decision. When installing a rotary converter, be sure to follow all applicable local, state, and federal regulations. Electrical codes and regulations are in place to protect people and property from electrical hazards. Contact your local building department or electrical inspector for more information. When working with electricity, always use caution. Electricity can be dangerous if it's not handled properly. If you're not comfortable working with electricity, then consult a qualified electrician. They have the knowledge and experience to safely work with electricity. Understanding motor starting methods for three-phase motors is very helpful. Motors draw significantly high inrush current at startup, and this can affect the performance of the rotary converter. Using reduced voltage starting methods like auto transformers or soft starters can help to mitigate this issue. Also, learning about power factor correction is important since power factor affects the efficiency of power usage. Improving the power factor can reduce the current draw and improve the overall efficiency of the system. Capacitors are commonly used for power factor correction. Also, understanding harmonic distortion is also helpful, as it is the distortion of the voltage or current waveform which can affect the performance of sensitive equipment. Filters can be used to reduce harmonic distortion. Another element is understanding grounding and bonding requirements for electrical systems to ensure safety and prevent electrical shock. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical hazards. Bonding connects all metallic parts of the electrical system to the grounding system, ensuring that they are at the same potential. Finally, understanding electrical safety practices and procedures is essential to prevent electrical accidents and injuries. Always disconnect the power supply before working on electrical equipment and use insulated tools and equipment.